Welcome to qnawire.
Okay, so we're in chapter 29, problem 29 here. So we have this figure here where the rod is moving to the right here. So on top of rails, and it's moving at a speed of 1.3 meters per second. And it says it has a resistance of 2.5 ohms. And tells us this L, the distance of the rail separation here, is given as 25 centimeters. And it's all in a uniform magnetic field that is pointing out of the page, as shown here, with a magnitude of 0.35 Tesla. It also says the resistance of the U-shaped conductor, so that's the stationary bars, not the rod that is moving. So I'm going to call that RU, it's given as 25 ohms at a given instant. Okay. So part A says calculate the induced EMF. Well, because the velocity is perpendicular to the magnetic field and the rod, then we can use equation 29.3 to find the induced EMF here, and it's just given by the magnitude of the magnetic field times L times V. So this becomes 0.35 Tesla times 0.25 meters times 1.3 meters per second. And we get an induced EMF here of 0.1138 volts. Cool. So let's move on to part B. What does it ask? It says the current in the U-shaped conductor. Okay, well, if this is the induced EMF, then we can use Ohm's law to find the current as just the EMF over the resistance. And we'll have to use the total resistance here, and since the U-shaped conductor and the rod are in series, we can just add them. So this is the total, so this is also EMF of the rod resistance plus the U-shaped conductor. So this is 0.1138 volts over 27.5 ohms. And this is a current of 4.138 times 10 to the negative 3 amps, or roughly 4.1 milliamps. Okay, cool. What does part C ask? It says calculate the external force needed to keep the rod's velocity constant at that instant. Okay, so the induced current in the rod will be down. Because this current is an upward magnetic field, there will be a magnetic force to the left, right? So the I induced is going this way. So it's down the rod, and using the V cross B to find the force of the magnetic field gives you a force pushing to the left. So to keep the rod moving, there must be an equal external force to the right. So what that is it's given by ILB, needs to be the equal magnitude of this. This is the force to the left, so we need an equal external force to the right. And this is, oops, not 0. This is 4.138 times 10 to the negative 3 amps times 0.25 meters times 0.35 Tesla. So this is a force of 3.621 times 10 to the negative 4 newtons. And this is what our F external needs to be to keep it moving constantly. Cool.